MTG, what's up, man?
Hey Jones, how are you?
I am good. I'm good. We've had back-to-back workshops today, and yeah, it's been fun.
Yes, yes.
but but the one earlier was showing the Breeze SDK, and it's super cool. I'm very interested for when they get the WASM integration because right now it's mostly focused for web, for mobile, or like
Mm-hmm.
system, like access to the operating system. But I'm yeah, going to be super interested to see what happens with WASM. Maybe I'll be integrates it and stuff. So that'll be super
Uh-huh.
cool. Yeah. Uh,
Yes.
how have you been, man? You've been planning this series for a while now.
Yes, it's been kind of like at the beginning it was a little bit just an interesting idea, but like as you dig more into it, you discover more stuff, and yeah, it's cool. Like not so much lightning, but like a mix between lightning, AI, and stuff. It's kind of fun to work with these two mix.
I mean, I keep saying this at every event that we have. It becomes interesting, any product, any software, whatever, it becomes interesting when you mix multiple domains together, right? I think it's very rare when you have like something super impactful like that works across for like a large set of people that's only focusing on like one specific technology stuff. But that's where the early adopters come in, right? The early adopters, the enthusiasts of a technology, they're super focused on it, and I think that's what we've seen in Bitcoin so far, right? The
Mm-hmm.
people with making software, it's like for Bitcoiners, it's for the other enthusiasts. But when we start mixing in technologies from like around different like avenues and stuff, then we get some very
And not
interesting
any
hype.
technologies, like two of the most interesting technologies.
That's the most.
So
Yeah,
yeah.
yeah. I sent out some tweets just now. I said, if someone wants to create a rhythmic AI chatbot that takes payments, that's greedy, a greedy rhythmic AI chatbot, right? So we have what? We have rhythm and rhymes, we have AI, and then we have payments as well. So, I'm pretty sure it's going to be a fun talk.
Hmm.
Um,
Yes,
as
hope so.
everyone knows, we're doing the AI for All hackathon. It's uh, it's been what, yeah, 10 days already since it started. We kicked off on the 1st of July. I gave some of this. Yeah, I gave the lowdown in the last talk, so I won't go on too much about it. Um, But yeah, I want to really thank our sponsors and the people who put on this hackathon, Fedi and Stackwork. Also, big up to Repolit, who we're in collaboration with, as well as the sponsors HiveMind, Spirito Satoshi, Prem, and Zebedee. Some of these companies and projects have some big announcements coming across the month. This is AI month, AI plus Bitcoin month. That's what I want to call it. First 2 weeks are education, right? This is our last big education week, but we're still going to have programs. We're still going to have mentorships for um, anyone who wants to get help or needs to still learn about some of these concepts. There's some big prizes as well. MTG. When do we get to actually like attend one of these hackathons, man?
You mean participate
Yeah, when do we get to
uh,
participate? Is it just too
when we are
fun
not one of the organizers.
when we get one of the organizers? But it's fun organizing it as well. I must admit, it's nice
Yes.
giving people a platform. I met some folks in Prague who attended our hackathons and stuff, and it's like I hope one day you get to like meet some of the folks at these like that attend our virtual hackathons because most of what we do is in virtual space, right? So we're always behind the computer, and especially MTG.
Yeah, true.
We need to get you out and about, get you some Bitcoin conferences. I want to retire from them to put you there instead. But
Uh-huh.
it's really
Let's
kind
see.
of surreal when you meet people. It's like, oh, you're from Boltwa, and I'm like, yeah. How do you know?
Meeting them on site now feels weird instead of meeting them online, which like
Right?
it used to be the other way.
Exactly. Because I'm just not used to it. Like it's all virtual. You don't think much of it, right? But anyway,
Yes.
but you thought very much about your presentation. Feel free. You don't need to rush. If you want like the full hour and stuff, we started a bit later. If you want the full hour, you go 15 hours. 15 minutes, not 15 hours. 15 minutes ahead. Feel free. But yeah, maybe from to begin, let's kick it off.
Okay. Just one thing. Should at the end, like, we keep some time for FAQ
Sure. I mean,
or
we could run it over. This is the last talk of the day, so you're free.
okay.
Alright, there you go. Wait, hold on. I think we're experiencing some technical difficulties. Give me a second. MTG?
Uh,
Hmm. Okay, I think it's settled now. Can you try talking? Yeah, it's I'm gonna check the stream now just to make sure. It's not just me. Hey MTG? All right, sorry about that. We're experiencing some technical issues, I think, on MTG side, according to. Sorry about that. All right, let's get MTG back up. Hey, can you hear?
Yeah, I can hear you.
Okay, I can hear you fine as well. So let's just do the slides first, and then you'll do the presentation screen so that you don't have too
Okay.
many things uploading at a time.
Oh, yeah. Okay,
Yeah,
so I'll not share my screen.
you
Right.
not yet. Yep.
Okay.
Python 360 in the building. Really excited to see. I saw you made a post there recently. I'm gonna check it out. Didn't get a chance this weekend, but excited to see what you're working on. All right, MTG, let's go. Let's
Okay,
go.
let's go. We lost so much time already. So, first thing first, welcome everyone. This will be a quick workshop about building an AI chatbot that you can pay with Lightning payments. Um, very quickly for people who like who's first time seeing me, my name is Muhammad Taher Ghazal. I work currently with SpeakShift. I'm the main developer behind the Bolt Fun website, and I work on like several other web projects, WebLN stuff, Nostr stuff, etc. Uh, Now, this workshop will like primarily be, it will not be WebLN focused because I think already there has been some other workshops that focused on that. So I will not like repeat the same stuff that they already uh, said. Instead, we will focus more on the client side and the interaction between the client and an API powered by AI and WebLN. Um, So, very quickly, let's take a look at the actual application. Because we don't have too much time, we will not be coding it live right now. We will just go over the different parts and explain them as we go over them. So, I'll share my screen right now. Um, Here, you can see it, right? Yeah, I think so. So, this is a very basic UI where the user writes something. Hi there, chatbot. When you hit enter, an invoice is fetched. Uh, now, this is, as John's mentioned, this will be a multi-part series. The first part, we will try to make it simple. So we will like go the approach where with each prompt the user write, we will ask the user to pay for this prompt. In the later parts, we will try to do a more like better versions where we can use L402 or some other stuff. So for this version, we will like go with the approach that with each prompt the user write for the chatbot, we want to ask the user to pay some amount of sats for this prompt to be processed and a response to be returned. So uh, an invoice appears here. The user can pay it with WebLN if he has some WebLN extension like Albi, or he can use his mobile wallet. So I'll pay it with my Albi. Okay, now it's paid. As you can see, it's generating a response. Now, behind the scene, the API is connecting to the OpenAI API and sending it the prompt and specifying which AI model it wants to use. And we'll see all of that later in the video. And it returns a response. Hey there, friend, what can I do for you? A question or a joke? I'm here to ensue. Uh, it's like a friendly chatbot that returns its responses in rhythms to make it kind of fun. One other thing that maybe you have noticed, if we try to say another message in there, that there is this don't show this model in the future, instead use WebLN to pay immediately. This checkbox, if you click it in and pay, in the future, like instead of this model appearing each time the user writes a prompt and hits enter, it will like try to automatically in the background request WebLN payments to be made, just to make the process easier. But we'll also talk more about that. So this is the app that we'll be going over, basically. Uh, Now, aside from that, let's talk about the now this is the user journey. Let's talk about the technical journey in simple terms. So when the user first writes a prompt and press enter, we want to generate an invoice for this specific prompt and this specific message. Why? Maybe because, for example, we want to take into account how many uh, tokens this prompt has, because as you might know, OpenAI API charges based on the number of tokens that you send to the API and it returns. So like it does not charge a fixed amount. So maybe the invoice that you want to generate also depends on the number of tokens that the user has in his prompt. Uh, so after the API generates an invoice and send it back to the client, we show the model that you just saw, uh, and the user is expected to pay the invoice here. So after the user paid this invoice, we verify his payment somehow. Like if you have a Lightning node, maybe we build the API and check to see if this specific invoice is settled or not. If we are using Lightning addresses that support LN verify, we can use that, which is the one that we'll be using. Whatever. After we like confirm that the user has paid, the client will make another request with the API, but this time including the pre-image. This way, the API will know that this request has been paid and it can verify that however it wants there. It will then connect OpenAI API, generate the response for this prompt, whatever, and return it to the client. This is the general technical flow that is going on behind this application. So now I think for the slides, yeah, I think that's everything we want to talk about theoretically. We can jump right into the code. Mm, I, I'm not sure if you can see the window, but I think, yeah, you should be able to. So the application for this project is a simple React application, client application for the front end. And for the back end, I'm using just like the backend is actually just two serverless functions. I'm using Netlify functions for that, but you can use whatever like Express server or whatever, because it's the API is very simple. The most of the code is in the front end. So back to our application to see like we will start with this message container, this component. Uh, I will not like talk anything about uh, styles or anything like that. I will just focus on the parts related to the WebLN, to the payment, etc., and related to the AI API. So simply like here, I just show the list of messages that appear here, and this is the form that the user can write into. The important part here is that when the user hits enter, I call this function on submit message. This function will call another function, an asynchronous function called submit message mutation that I created. Uh, let's see what is inside that. Now, just like before I go into that, I want to clear to one thing, that I have created two React contexts just to make the code reusable. Like it's a little bit probably more complicated if I put it just in the same component or in the same file, but I tried to make it in a context so that if you want to like copy paste it and reuse it in your own application, you can just go to the context and copy stuff from there, because all the logic related to the payment or chat is located here in this context, React context, but and the components only has like the logic related to the component themselves, showing loading states, etc., showing errors or whatever. So I have two main React contexts. One is related to the payment, fetching invoices, showing the model, handling the state of the model, whether it's like shown, hidden, what is the invoice it's showing, or whatever, and calling also the API. The other context is the chat context. It just like handles the state of the main chat component, like what messages it has currently, in which state the button is in. Like you saw when we wrote the message and we clicked on send message, the button first displayed generating invoice. Then after the user paid the invoice, it showed generating response. So like just to keep the user not just seeing a looping a loading spinner in front of him, but instead like try to keep him in the loop, so like he knows which step is currently going on. So yeah, that's the two main contexts we have. So back to this message container component. When you click on this send message, this function will get called from the chat context. Now what this message will do is, aside from like on status update, this is just a function to update the status of the button. It will first try to request a payment and wait until it's been paid. This request payment function comes from the payment context. Uh, and let's go see what is there. Here. So this request payment function will first call the API and ask it to generate an invoice with some amount. The API will return this invoice, and it will also return a verify URL. This verify URL, you can, let's actually call it and see what it is. If here I open the inspect menu and I say, how are you? I see here there is no requests yet. If I hit send message, you see it called a get invoice request. The response of this request, I'm not sure if it's clear. It returns four fields, a JSON object with four fields. The first one is payment request. This is the invoice that is shown in this QR. You can, if you want, copy paste it. You can use WebLN. The payment hash, if the client wants to make use of that, and a verify URL. If you just copy paste this verify URL and go to another tab, paste it, see it returns a JSON object saying that like it tells you the state of this invoice, whether it's paid or not. And as you can see, the settled field is false and the pre-image is null, so it's not paid yet. If we go back here, I click on the QR code and pay it. Okay, now it has been paid, and as you can, all these requests, by the way, are will like we will just come to them in a moment, but they are just polling the API to check whether the invoice has been paid or not. Okay, so after I paid the invoice and got the response back, if I go back to this same verify URL and request it again, you can see that the response returned is now different. The settled field is true, and now it has the pre-image, uh, which is the pre-image is, if you hash it, you get the payment hash. So uh, now, of course, one thing worth noting is that not all LN providers support LN verify URL or LN verify. Okay, this is something that Albi supports, but not all other providers support. If you don't want to use that, you can just connect your Lightning node. Let's actually go quickly into the API function for this. It's very simple. I'm using Albi tools. I'm getting a Lightning. I'm putting my Lightning address, and then I'm asking, like I'm calling the request invoice function on my Lightning address. I'm passing it the amount that I want the invoice to be, and yeah, like because my Lightning address is on Albi, I know that it will have a verify URL, but otherwise it might not have. And I'm returning all these fields. Uh, this part is convert USDT to sats. It's just to uh, OpenAI API has their pricing in USD, right? Not in sats. So maybe you want to like put the amount of the invoice you generate in fixed amount of sats, but maybe you want to like change it depending on the price of Bitcoin to USD dollar. So here this function, I'm just calling an API that like can return to me the it can convert the price of USD to Bitcoin. So I'm sending it the amount of price I want in USD and then converting it to sats and putting it here. But you can, like, if you don't want to do that, you can skip that, of course. So uh, now, after we get the invoice and we show it, yes, let's go back here to the payment context. So here we get the invoice, we get the verify URL. Um, After that, I show the user the payment model. Uh, where this happen is here. If we have a like if the verify URL gets set, and like as you can see, we have a state variable called prefers to pay immediately. This variable will be true if the user here clicked on this checkbox. Well, if the user checked this checkbox, then this prefers pay immediately will be true. If the prefers pay immediately is true, I will not show the model. Instead, I will immediately call webln.send payment, and I'll try to make this the user webln extension pay this invoice in the background without showing any pop-ups or whatever. But of course, the user needs to have set a budget and like connected to the website. If it fails for whatever reason, you see here there is a catch. If this like pay with webln in the background fails, then I will like first show a quick error message telling the user I like we tried to pay with WebLN but we failed, and then we will show the model to the user so that he can try to pay with his mobile wallet, for example. Uh, so now whenever the model is shown, I need to make like to check to see whether the invoice has been paid or not, right? Like if I am only supporting WebLN, I can just wait for this function call to return a success and I can hide the model. But what if the user uses his mobile to pay for the invoice? I need to know that the user has already paid the invoice. So that's where this use effect comes. Uh, if there is a verify URL state, it's being set here, by the way. After we fetch the invoice, we set this variable. So if there is this verify URL state, I will trigger an interval. In this interval, every 2 seconds, I think 2 seconds is too short, maybe. Like, I think it's fine if you put it 3 or 4, 5, whatever. So each 2 seconds, I call the verify URL that we just saw, that we, this one. So we call this verify URL and we check the settled and pre-image fields of it. If the settled, or like we rename it to is paid, is true, then we know that the user has already paid his invoice. So first thing, we stop this polling interval and we hide the payment model, and we call this on payment success callback with the pre-image. So this on payment success callback, whenever it's called, we will go back to this chat context here,
Hey there, MTG. I just saw this message come in from there. It said the font is very small. Could you zoom in, please? So maybe we could make your screen size a little smaller, or maybe I'm not sure, but yeah, maybe zoom in like two more times. That might be a little. Okay, I think that should be fine. And then yeah, on the web pages when you're showing it off, maybe also the same. Okay.
Okay.
All right. Cool.
Here, like this, it should be fine.
Yeah,
Is
looks
this
good.
good right now?
Looks good. Yep, looks good.
Okay. Okay, so we were here. Uh, After the on-success callback is called, and the user just paid his invoice, and we got the pre-image. What we do next is we make the actual API call to get the OpenAI API response, and we send this pre-image as a proof that the user has paid for this invoice. So here in the API function chat, we get a request. The body of the request has two things: the messages and the prompt. Now, let's talk a little bit about OpenAI API. OpenAI API has like several models. It's not just the ChatGPT model. It has many. Like it has images generation, embeddings, moderations, and the GPT models. So let's actually go quickly to the GPT AI, and let's go, for example, to their um, pricing page. But like you can see, they have the GPT-4, GPT 3.5. They have these different text models. They are not conversation models, embeddings, or image models. And each model has a different, like a little bit different API and different pricing. So it depends on what you want to like use or your use case. In our case, it's a chatbot, so it makes sense to use either the GPT-4 or GPT 3.5 models. Now, these models, what they take is like if you used the ChatGPT application, web application, you, you might think that the like they are storing your conversation history, and like you are just sending when you are writing a message and you hit enter, you think that they already have your previous messages stored, and they just like make a request only with the new message that you just wrote. But the thing is, each time you want to make a request to the model, you have to like give it the whole conversation history. So, like if there is already 50 messages between you and the chatbot, and you want to write a new message, so you need to send the 51 messages to the model and ask it to process all this conversation. So that's why here the messages is a list of all the messages so far that the user has written. The prompt field is the new message that the user just wrote. Uh, we extract the pre-image from the headers. We expect the client to put the pre-image he just got from the invoice in the header and send it along the request. Now, the first thing we need to do is to make sure that, like, we need to make sure that this pre-image is valid. It's a pre-image for an invoice that our API generated, and it has not been used before, right? Uh, like, we don't want the user to send us any pre-image and we will just fulfill his request. So when we were like here in the get invoice function, When we generated the invoice, we added it to our like to a database. Here I'm using a simple MongoDB database. I'm just adding the like storing the payment hash of this invoice. So here in the chat function, I first uh, calculate the payment hash from the pre-image. And as I mentioned earlier, the pre-image, if you like apply the SHA-256 hashing algorithm on it, you will get the payment hash. So after getting the payment hash, I check the database to see if I have uh, like already an invoice that I created with this payment hash. If I don't find such payment hash, then the user has sent me a pre-image for an invoice that I did not generate, and we return 400. Otherwise, then the pre-image is valid and for an invoice that we created. So here we call the OpenAI API. Uh, OpenAI has an NPM package, by the way, that has multiple abstractions over their API. They have um, a RESTful API that you can call using Axios or Fetch if you want, but OpenAI package provides some nice abstractions, classes, etc. Like basically like an SDK on top of this API, so that you don't need to write URLs. So one of these classes is the uh, chat completion request. No, sorry. One of these classes is this one, OpenAI.create chat completion. This is a function that you give it multiple parameters, like first the model that you want to use. In our case, we are using the GPT 3.5 model. However, you can here, I think, write GPT-4 if you want, or there are multiple other models like Ada or DaVinci, uh, etc. And as we mentioned, each model has its own uh, capabilities and pricing. So for a chatbot, the GPT 3.4, 3.5 should be more than enough for most cases. The second parameter that we give it is a list of messages. These will be like a list of objects. Each object represent a message. They are ordered, by the way. Each object represent a message that has been in this conversation so far. And the first one could be uh, a system message. What like it's optional, but you can supply a system message. A system message is basically like just some instructions that you give to this model to act on during its uh, response generating. So, for example, you can here in the system message say that you are a bot that translates from English to France. So whatever the user writes later, he does not need to also write, please translate this sentence from English to France. He can just write some sentence, and the model will immediately uh, translate it to France and return the response. So yeah, that's the role of system message. So the system message that we have is that you are a funny chatbot who always reply in rhythms. And we can also supply some extra instructions. Like in our case, I told him, but try to keep your replies around 1 to 3 paragraphs. Uh, Maybe you can tell him some extra instructions like your replies should be in JSON format, your replies should be in HTML. Try to make your replies as a list or whatever you want. Next, after the system message, we like go over the messages that the user sent. But just like one thing we do before that is we filter them and we like remove any message that has a role other than user and assistant. This way, we make sure that the user does not also supply another system message. We just assistant represent chatbot. May want to make sure that the user only send us messages as a user and as a chatbot. And finally, we put an object that represents the user's latest message or prompt. When the API returns the response, the first thing is we remove the payment hash for this pre-image from the database so that the user do not like reuse it later. Uh, Maybe you don't want to remove it. Maybe you just want to mark it as paid. For example, if you want to keep track of how much invoices have been paid, how much invoices you have generated, whatever, or you can remove it if you want. After that, we just like return a simple 200 status with the response. Um, like, by the way, the OpenAI chat model can return multiple responses, not only one response. That's why we are here saying choices zero. But you can instruct it to only generate one response or two response or whatever. It's up to you. Of course, the more responses it generate, the more costly it will be because it's using more tokens. So let's go back here to the code, chat context, the pre-image. So here, this is the response that we get. We update the status for the final time that the response has been fetched, and we update the list of messages in the UI and append this new message that we just got and mark it as a bot message. So yes, I think we have two other things that we should cover. One of those things is showing this checkbox. Uh, this checkbox like we said that we use it because the user like it will be a tedious experience if the user has to see this model after each uh, message he types and the bot respond to him. So we show this checkbox. However, what if the user does not have a WebLN extension? Like if he check this box and he does not have a WebLN extension, each time later he try to write something, hit enter, he will first see an error message, then he will see the model again. And okay, he pay it otherwise and close it, and then type something again, he will see an error message again and see the model. So actually, we should not show this checkbox unless we are sure that the user has a WebLN enabled extension in his browser. And the way we can do that is simple. Here in the payment context, we have an is supported, I think. Oh no, sorry. In the pay invoice model, here, this is the checkbox that we are showing. Uh, yes, here it is. So before we show it, we check the is supported property on this WebLN class we have. Is supported, like how can we make sure that WebLN is supported or not? It's like simply we just check window.webLN and see if it's undefined. If it's defined, if we find any kind of object, then yes, there is a WebLN extension here. If it's not, then we can conclude that it's not here, and we don't need to show anything related to WebLN. So we don't show, for example, this pay using WebLN button because it will not work, and we don't show this. We don't show this auto pay switch. Okay, like we know that the user will use his mobile wallet. However, like still like keep the instructions telling the user to use WebLN extension because it will make his journey easier. One thing worth noting is that you should not check for window.webln immediately after the application starts. This is a very ugly bug that I like suffered a lot from, uh, because like the extension is the one responsible for injecting this WebLN object into the window object after a application starts. However, uh, most of the times it's not able to do that right away. It takes maybe sometimes a couple, maybe 1 second, 2 seconds. So like if this happens after you already checked for whether window.webln is undefined, and it's yes, it's undefined because the extension still is trying to inject it, and you hide all the webln stuff, you will not know why this happened. So what you can do and what you should do is like wait for 1 or 2 seconds maybe, or you can make this check lazy. So you only make this check whenever the user wants to interact with something related to WebLN. So in my case, uh, I don't make this check until the user opened the model for the first time. When the user opened the model for the first time, like I know that already enough time has passed, and if there is a WebLN extension, it should already have injected the WebLN object. So I make the check. So yeah, this is something that you should keep in mind. We should encourage the user to like. It depends on the type of application you're building, but in the kind of application where interacting with WebLN will happen like with a high frequency, like in our case, uh, chatbot, or maybe you have an application where you're showing a list of stories and you can uh, tip some stories. So these frequent interactions with the WebLN, uh, it will be tedious if the user see a model each time he try to make these interactions. So try to encourage him to set a budget and like ask him the permission to try to make these interactions in the background. It will improve his experience like by a lot. Um okay, I think that's most of the stuff. There are a couple of things I want to mention before I wrap things up regarding the OpenAI API. Just some like instructions to keep in mind. The number, like I mentioned several times, that the API like charges based on the number of tokens you use. But like, what does tokens mean? It does not mean the number of words nor the number of letters. Tokens are like something special to, like, it try to split each sentence into multiple tokens. Maybe a token is a single letter, maybe it's 4 letters, maybe it's one character or whatever. Uh, but like in general, each token is around 4 characters usually. So there is a limit for the number of tokens you can send in any request, and like we mentioned earlier, that like each request you need to send the whole history of the messages that you have. So what can you do if the user like keep typing and talking with the bot and he exceeds the limit of the tokens that you already have? For example, here in the pricing page, we see that GPT 3.5 has a maximum number of 4K context token. So you cannot, like, the maximum amount you can of tokens you can set is 4,000, or you can use the 16,000 context, but it's like double the price. Uh, so what can you do to fix that? there are several strategies you can do in a chatbot context. One of them is like you remove the oldest messages. This is the easiest method. Uh, but like you might lose some info. Uh, so like if the user in the first message said, "Hey, my name is Muhammad," and then in a later message asked about what was my name, and you already deleted this message, it will say, "I don't know, you haven't told me your name." So another way that you can use if you don't want to delete messages is to use a summary API that will, like, you can use ChatGPT on API for that. You can give it a list of messages and you ask it to summarize them in a much shorter uh, number of paragraphs. And instead of supplying, for example, 15 messages, you now just supply one message that contain the summary of these 15 messages. This will keep the length in check.
So at what point will you be actually like calling that summarization kind of like API or like
Yeah, it's not,
a
as
task?
I said, it's not a
Yeah, yeah,
different
the
API.
task, the
It's like
task.
the same. Yeah.
Yeah.
Uh, One other thing you can do, but it's much more advanced, is you can create embeddings for the messages that you have, and you keep them stored in your database. And depending on the user prompt, like you compare the embeddings of the user prompt with the messages that you have, and if there is something similar, you include them. And by embeddings, I mean like they also have this, by the way, in their API. Embeddings mean extracting like some vector number from a text, which like it refers to some of its meaning, I could say. Like it's usually used to compare two pieces of text. It's used in search engines or with recommendation engines or whatever. But it's, as I said, it's a much more advanced use case, and most of the time you will not really need it. Like unless you are creating a very uh, like a chatbot that should not really forget anything, and it's not just a chatbot, basically, then you should not need that. Uh, but yeah, I think that's most of the stuff.
That's a fantastic kickoff to the workshop, MTG. We do have a couple questions. You kind of touched on this a bit, but uh, Bumi asked, I like this payment model. Could it be a reusable widget that people can recognize on different pages and like include?
Yes. Yeah, yeah. I think yes. Like when I was creating it, that's what was in mind. That this model should be reusable and like hopefully just like you can take the context and the model, throw them, and you can call them anywhere and they will appear anywhere. That's
Yeah,
the intention.
and yeah, we'll be doing some more work in that modal as well because one of the design things that we were trying to solve, actually, maybe you can pull it up on the screen again, MTG, just quick. The
Uh,
modal,
the
the
model?
modal, yeah. Just for context for some folks, when you get it
No,
up,
it's doing the auto payment.
you gotta
Okay.
let's see, where is it?
So,
Yeah, yeah, maybe zoom in a bit on there. Okay, yeah. So, no, that's good. Yeah, so with this modal, the way in which we try to design this is so that, you know, assume someone doesn't know about Bitcoin. They don't assume that they don't have Bitcoin. We need to be able to kind of like onboard them, help them get a wallet, et cetera, et cetera. So that's the thinking behind it. We would love some input and some help from you guys. I think one of the problems that it has currently is we need to do help people figure out how to fund their wallets initially, how to get that first set of Bitcoin initially, especially since we're dealing with lightning payments, right? But yeah, you have the two options, whether it's to scan or whether it's to use WebLN. It works with this chatbot. We have to assume that, like the masses of users, um, the massive users, making AI apps and stuff like that, they might not already have Bitcoin. So, um, yeah, we need to figure out this. We'll be doing a design workshop later in this week as well. So stay tuned for that. We'll go into some of like the design decisions. I think it's going to be a short one, but just a short workshop on this model and like the UX, other parts of the UX around the payment flow. But yeah, MTG, this was awesome. Where shall people reach out to find you?
Mm, I
Hmm.
think primarily on Discord.
You're on
Or
at MTG Dev on Discord.
by the way, I forgot to mention that the code for this project is available on both Replit and on GitHub. You can
Can you
find it.
send the
I
thing to me
think
on DM?
this
The
one.
replit.
Uh, where should I send it? Here in
Uh,
the
just in
Steam
Discord.
yard.
And you can send us PM and StreamYard, yeah. Yeah, amazing again. So I guess yeah, they could follow you on Replit as well. We'll put your Noster down in the chat, in the description as well. And yeah, thank you, MTG. Really appreciate it.
Yeah, glad to be here. And if anybody has any other questions, feel free to send them on Discord later. Either like DM or on the workshops channel,
Or
wherever,
on Bolt
or
Fund.
on Bolt Fun server also.
Come on, no, you can no on Bolt Fund itself. Get to Bolt Fund. We need to show
Yes,
that
yes.
one too. All right, MTG. Thank you so much.
Thank you, Jones.
Ciao, ciao.
Thank you, everyone.
Take care, everyone.